Recording. So we are today solving equations by graphing. What we're going to have are polynomials like this with equal signs. We got stuff on the left side, stuff on the right side. And our goal is to find the x's that make the equation true. And we are going to use the calculator to figure it out. Yay. So we can solve these by graphing both sides of the equation separately. Ooh, that pen is too large. So both sides separately are those blanks. Sorry, the separately blank is kind of small. So the left side will be y1, right side will be y2. That's what it means by separately. And finding the x values at the points of intersection. Supposed to say values, not valves. All right, so basically what this might look like is, say we have a cubic, makes like an S shape, and then a linear going through it. How many points of intersection does that have? 3. So for this one, you would have 3 answers. All the x values for those 3. And you use your calculator to find them. All right? Okay. So go to your calculator, put this left side in y1 and this right side in y2, and then graph them. So it should look like this in your calculator for y1 and y2. And there's your graph. If your window is crazy, remember you can always press zoom 6 and it'll get it back to like the standard, the normal. Anyone need help getting it to here? From here, we will use our calculating part of the calculator, but the second trace, which is calc, second trace. And number 5 is intersect. So that's the one you're going to use. Now you're going to have to do it 3 times for the 3 separate points. And we can watch it happen here. Alright, so we're going to start out trying to find this one. So second trace, go down to number 5. I'm going to arrow over until I'm closer to that point. Alright, so I'm pretty close now. So I press enter, enter, enter. And I'm going to write down my x answer. So x equals -3. We're going to write that down. And then go back and do it again. But now I'm going to go for that middle point. So I arrow until my little dot is closer to the middle point. And you get -1. Go for the last point. Get the calculator closer to that so it will actually look close to that. And I got 1. So those are your 3 answers. X equals -3, x equals -1, and x equals 1. Any questions, or can I help you do that? Second trace, and it should be number 5 in the option list. So the next one, it's fine that it just says -3. Put left side in y1, right side in y2. Find your intersection. This one, I believe, looks something like this. So you only had one point of intersection. What did you get for that one, Jacob? -1. As far as checking the problems like this, since you do it in the calculator, unless you type something in wrong, then there's not really a way you can mess up. But if you were going to check it, you would just take your x values. So say we start with -3. Plug it in for each of these x's and just see if the right side equals the left side. And then you do it for -1. Does right side equal left side? And then 1. Does right side equals left side? Most math problems you can always check yourself. But since we're doing the calculator, we won't worry about it too much on this one. Alright. Let's look at this word problem. You have one very similar to this on your homework. It says the dimensions in inches, that seems important, we got units, of a portable kennel, so that'd be like the little crate you take your dog or your cat to the vet in, okay, or lizard or whatever you have, can be expressed as width x, length x plus 7, and height x minus 1. Alright, all that seems important. Just underline it. The volume is 5.9 feet cubed. Also seems important. Find the portable kennel's dimensions. So it's saying, well, what is width, what is length, what is height? So let's see if we can figure it out. We know that volume equals length times width times height, right? So we could plug in all the little formulas it gave us for each of those. Length was x plus 7. Width was x. And height was x minus 1. What were the dimensions for all those three out of the first sentence? Inches. Okay. What can we replace the volume with? 5.9 feet cubed. What is our problem? One's in inches and one is in feet. So we have to convert. Hey, do you feel like you're in physics? No? Y'all don't do a lot of converting in physics? Or you do? Okay. So if we have 5.9 feet cubed, and we want to switch it to inches, so it's coming from feet going to inches, how many inches are in a foot? 12. Now, is that it, or what else do I have to do? Does our feet cubed cancel out with this foot here? No, you have to do it 2 more times, right, since it's feet cubed. All right. So times 12 inches over 1 foot times 12 inches over 1 foot. That makes all the feet cancel out, and we're just left with inches. So somebody put that in your calculator. What's 5.9 times 12 times 12 times 12? I think it's a pretty big number. $10,195.2, and that'll be inches cubed. All right, so that is what we can write over here instead of volume. Doing good. So in your calculator, put this in as y1. Put the right side in as y2. You do not have to FOIL and distribute all that. You can put it in the calculator, factored with parentheses. That's fine. But you'll notice that you cannot see the graph really if you aren't zoomed out. So if you will go to your window and make your x max, I think it's something like, if you'll make it 50, and your y max, it's got to be bigger than 10,000 something. So let's make it 12,000. Make that, then you should be able to see an intersection point and figure out what the x is at that intersection.
What did you say to me?
50 and for the x max and 12,000 for the y max. It should look something like that. If you zoom, if you set your window that way.
Y max 50, X max
12,000. Yeah. What'd you get for your x, Ty? So what'd you get? Anybody? 19.95. Let's round up. We'll just say it was 20. So what does that x represent? Part of them. Which one was just x? Width, right? Okay, so if width is 20 inches, what would the length be if it's x plus 7? 27 inches. And then height was x minus 1, so it's 19 inches. So there are your dimensions. It's not a very big kennel. Pretty small. Probably neither of my pets would, neither of my dogs would fit in there. The question on your homework that's the word problem, you do not have to convert. I don't think. So you can skip that step and just do all the others. On the back of the notes, we're not graphing anymore, and we're not even going to solve equations. We're just getting ready, okay? So there are some polynomials that we won't solve by graphing. I know, you hate me. That we got to do by factoring, okay? And there's some specific ones that are very special, and that's when you have just, it's like something cubed plus something cubed. That's it. You only have two terms. It's cubic, and each term is a cube. Okay? Or it's same thing. Each term is a cube, but they're subtracted. For those specific situations, this you have a shortcut of how you can factor it. All you have to do is figure out what goes in the A spot, what goes in the B spot, and then you fill it in back here. Okay, so these are for very specific situations. It's shortcuts that someone, somewhere, figured out. It wasn't me. So we are going to use those. Before we do that, let's just mark down some of our common cubes, just so you kind of have them right in front of you and you can remember them. What is 1 cubed? It's 1 times 1 times 1. It's just 1. Just 1. All right, what's 2 cubed? 8. 2 times 2 is 4. Times 2 again is 8. Okay, 3 cubed. 27, good. 4 cubed? Anybody? 64. Your calculator is helpful on this too. 5 cubed? 125, good. And 10 cubed? 1,000. Very good. Those, you might have other ones besides that, but these are going to be most of them that you see. All right. So, it says, if you factor x cubed minus 8 in this form that it has here, what is the value of a? So our first goal is that we have to get it in this form, and then we'll deal with the whole what is a thing. That form, though it's written slightly differently, is the same thing as this stuff up here. So let's use this up here. First of all, let's write it as something cubed minus something cubed. What is 8 the same as in cube form? Which one was it? 2 cubed. So we can write that this is x cubed minus 2 cubed. Our formula from the top, you don't have to write it again unless it's helpful to you. I just wanted them to be right next to each other so you can see it. I believe it's a minus b, a squared plus ab plus, oh, I messed up. Having zooming problems and mental problems. All right. So, because it was the minus, I used the second formula from the top. That makes sense, right? Okay. Now, what is going to take the place of the a's? X, just x. What will take the place of the b's? 2. All right, so every time you see a down here, we're going to replace it with an x. Every time you see a b down here, we're going to replace it with a 2. So instead of a minus b, I will have x minus 2 for the first set of parentheses. Instead of a squared, what will I have? What are we replacing the a with? X. So I'll have x squared. And plus. The next term is a times b. So it's x times 2, which that's not really how we say that. Yeah, we say it 2x. Okay, and the last part is b squared. Well, what was b? 2. So 2 squared is 4. All right. That's the first part of this question. Now the next part, it says comparing it to this form right here, which it's pretty similar to that, what is in the a spot for us? It's just a 2, because the x minus matches, a equals 2. So capital A equals 2. So all of that, the factored form plus the fact that a equals 2 would be your answer on that question. Pretty much what you got to do on these questions is figure out which formula to use, the one with plus, the one with a minus. That's pretty easy. Just look. Okay, and then after that, it's to figure out what are you going to plug in for A and what are you going to plug in for B. That's probably the hardest part. Let's do one more. Now, the one that I wrote on your paper is wrong. I had a brain lapse there. Instead of 225, make it say 125. Okay? So we want to write this as something cubed minus something cubed, right? What is, let's work backwards. 1 What cubed is 1? 1. Okay, so we can just fill in a 1 right there. So we got the last part. What cubed is 125? 5. So we need a 5 here, and we need our x. Does that make sense? Okay. So in our formula, what will we replace a with? What's in the first set of parentheses there? 5x. So this will become a, and what will become b? A 1. Okay, we're using the same formula that we did last time because this one again is subtraction. So the formula, if you want to write it down on your paper so you don't get it jumbled in your head, that's fine. Like on your homework. Okay, so every time you see a, replace it with 5x. So 5x. If you want to do it piece by piece like this, you can. And then now go replace all the b's with 1. So the first one would be minus 1. I got just trying to show you a different way to think about it in case it helps you. If you like the other way to think about it, then keep using that one. The tricky part here is that 5x needs to be in parentheses because we got to square the 5 and the x. So we'll have 5x minus 1. That was already simplified. What's 5 squared? 25. So 25x squared plus 5x plus 1 squared is just 1. So there's your answer. I think you have 3 problems like this on your homework.
Yep.
Yeah. So the first 9 problems on your homework are the ones you need the calculator for. So I would go ahead and do those. Maybe so you can leave calculators here so that my next classes have calculators to use. That'd be awesome. And then you can do the last 3 without a calculator.